This is lesson 4.1, solving quadratic equations. And the goal for this lesson is I can solve quadratic equations using a variety of methods. In fact, we're going to see that's the title or the goal for the next few lessons as we learn the different methods that you can use to solve quadratic equations. So first of all, hopefully you know what a quadratic equation is, different than a linear equation. A linear equation just has the value x in it, so y equals, for example, 1/4 x minus 7. You just have x to the first power, and that makes it a linear equation, makes a line when you graph it. Quadratics, on the other hand, have an x squared in them, so y equals x squared, for example, plus 2x minus 9. There's a good example of a quadratic because it's got an x squared in it. And that x squared term is called the quadratic term, and the 2x is called the linear term, and then the 9 is called the constant. So one method to solve quadratics is to take the square root. So you need to understand what a radical is and a root is, the vocabulary of those. And so the number x is a square root of y if x squared equals y. So the square root of 9 is 3 because 3 squared is 9. So that's like 9 would be the y and 3 would be the number x in this case, and it would be the square root of 9. Okay, and the symbol that looks like a check mark with an extension there, that's called a radical, right? And it indicates the root of a value. And every real number has two square roots. It's important to understand that not only is 3 squared 9, but negative 3 squared is also 9. So there are two roots, a positive and a negative in most cases. Okay, the positive root is called the principal root. For example, the square root of 4 is 2, and it's also negative 2. And students often make the mistake of typing this into their calculator and saying, well, Mr. Williams, it tells me that the negative 2 squared is actually negative 4. Well, it's because the calculator does exponentiation before it does negation. And so it's going to say 2 squared is 4, and then it's going to negate that and make it negative 4. In order to square negative 2 appropriately, you've got to put it in parentheses. Okay? That's going to make the positive 4. So not all numbers, obviously, are perfect squares, right? In fact, most are not, but here's a list of the first 10. And I'm sure you're familiar with those, and you can figure out what the square root of those are. So how can, what's the difference between these three problems then? What's 8 squared? And I already talked a little bit about this on the previous slide. Which result in perfect squares? Well, 8 squared is actually 64, which is a perfect square. And then if you put negative 8 in parentheses and square it, you also get a positive 64. But like I said before, if you don't have the negative 8 in parentheses with the square on the outside, it takes the 8 and squares it and then negates that and makes negative 64. So understand, square and square root are inverse operations of one another. It's one undoes the other, just like addition and subtraction are inverse operations, and multiplication and division are inverse operations. So if something is squared and we need to get rid of the square, we do the square root, and that's the inverse operation for that. Okay, so the square root of 8 squared, well, the square root and the square, they just negate each other. It's simply 8. Okay, so steps to solve using square roots. You have to isolate the squared expression on one side of the equation. Just like solving linear equations, you're just going to use inverse operations. You may add or subtract terms. You may multiply or divide by terms. What you don't want to do is, if you see parentheses with a square, you don't want to multiply that out. You want to leave that alone. That's what's being squared. Okay, so if you see something like the quantity x plus 2 squared, don't square x plus 2. That's reversing our direction. We need to work to solve. So we can take the square root of this. This is the expression that's being squared. We need to isolate that. Okay, then you square root both sides to remove the square root. Make sure you write a plus and a minus in front of the constant on the other side of the equation. We'll see that. Isolate the variable using inverse operations, just like you would solve a regular equation at that point. And be sure to write all the solutions to the equation. So you may want to split the equation into two, one equal to the negative root and one equal to the positive root. So when is it good to use the square root method to solve? Well, when you have just x squared without x, okay, so no linear term, Or you have this expression right here is being squared. So some value a times x plus or minus a value of b, and then that quantity is being squared. So we don't multiply that out, we end up taking the square root to get rid of that square there, okay? So here's some equations we can look at. Now, what do you notice about all the equations on this page? Hopefully you notice that there's no x term, there's no linear term, so we just have quadratic terms. So for this problem right here, the x squared is already isolated. I'm ready to apply the square root, so I'm going to square root both sides. On the left side, that just becomes x, and what is the square root of 36? Well, it's positive and negative 6. On the next example, we've got a 3 in front of the x squared. Well, the x is the only thing being squared. I need to isolate the x, so I'm going to divide just like I would in solving a linear equation. And x squared is equal to 27 divided by 3 is 9, and I'm going to then take the square root of both sides, and x is a value of positive and negative 3. So you guys try that next one, and then, oh, you've got something to try at the bottom. I'll do this one. So this time the x squared is, again, needing to be isolated. We've got a positive 13 there, or a plus 13, and I'll just subtract 13 like I would in any equation. 62 minus 13 is 49, and then I'll square root both sides, and x is positive negative 7, okay? So you try those next three. Shut the video off and turn it back on when you're done. All right, hopefully here you just simply took the square root right off the bat of both sides. It's ready to solve, positive and negative 9. The next one, you're going to divide by 4 first to get x squared by itself. And then we have x squared equals 25. I'll square root both sides, and x comes out to be positive negative 5. Here I'm going to add 12. Then that's going to make x squared equals 64. I'm going to square root both sides, and x comes out to be positive and negative 8. Now I want you to notice that the exponent can predict the, I'm sloppy here, so sorry, number of solutions. So an x squared equation is going to have 2 solutions, potentially. An x cubed would have 3 solutions. Well, a linear just has 1 solution, right? Okay, so that's why we're getting 2 answers. We expect 2 answers when we see an x squared. So, and they're coming from that positive and negative root in this case. Okay, we'll see how x cubes work a little later in the semester. Okay. So here's a little tougher. I'll try the top 2. You try the next 2 there. So we've got, first of all, I'm going to get rid of this 2, minus 2 from both sides, right? That's good equation solving. Minus 3x squared equals, and that's negative 48, and I'll divide by negative 3. And x squared equals 16, and then the square root of both sides gives me positive negative 4. Here's one where we got that binomial squared. We got these 2 terms in parentheses, this expression x minus 3. The whole thing's being squared. Do not multiply this out. Okay, don't expand that. You want to isolate it. Okay, so I'm going to add 400. I'm going to get x minus 3 squared equals 400. And now I square root the entire expression to get rid of the square. And then I have x minus 3. And on the other side, I have the square root of 400, which is positive and negative 20. Now I have to solve for x by subtracting 3. And this is where I mentioned that you might want to split it up. You might want to write x minus 3 equals 20. And x minus 3 equals negative 20. So here you add 3 and you get 23. And here you add 3 and you get negative 17. Okay? So now all of a sudden we don't just have positive, negative, some number, because we had other mathematics to finish before we declare our answer here, right? So we had to do that addition of 3 there. So you try the next 2, stop the video and see how you do. All right, so I think plus 25 on each one of these. So that gives me 25 and x plus 4 squared. Now square root both sides. X plus 4 equals positive and negative 5. So that would be x plus 4 equals 5, and x plus 4 equals negative 5. So if you subtract 4 from each, you get x equals 1. And you subtract 4 from negative 5, you get negative 9. Okay? This one here, I'm going to add 13. Get negative 2x squared equals negative 111. So we get negative 98. And then divide by negative 2, and we get x squared equals 49. And then square root. This does give a positive negative answer. Okay? All right. What happens if you don't get a perfect square? Well, let's see. Well, we'll just add 5 and add 5. We're going to isolate the y squared, right? That's a 139, 144. And we divide by 8. Oh, my pen switched to an eraser immediately there. Sorry. There we go. And then we square root both sides. We have this 144 divided by 8. And if we square root this fraction, well, I get the square root of 144 is 12. But what's the square root of 8? Positive and negative. Well, we have to break 8 down into some factors. Square root of 8 is square root of 2 times square root of 4. And the square root of 4 is 2. And the square root of 2 we don't know. Now, if you don't understand how to break it into a perfect square and a constant, you can into some other value, you can continue this tree like this. You can do 8 breaks into 2 times 4, and then 4 breaks into 2 times 2. And then every pair of factors here has a perfect square equal to just one of them. So like 2 times 2 is 4, and so this pair of 2's is going to become a single 2 on the outside of the radical. But then anything that's not paired up stays on the inside of the radical. So we get 2 root 2 for these. So now I've got this positive 12 divided by 2 root 2 and negative 12. So then 2 and 12 cancel, giving us basically this, 6 over root 2. Well, then if you remember from Algebra 1, you can't leave a square root in the denominator, so I'm going to rationalize it by multiplying by root 2 on top and on bottom. So this is really essentially, this is just a 1 right here. Root 2 over root 2 is 1. So it doesn't change the value of the fraction to multiply by 1, but it just changes the way it looks. It changes the format. So I get 6 times root 2 over root 2 times root 2, which is root 4, and now that root 4 is 2. So 6 root 2 over 2. And then 2 goes into 6 3 times, and so my final answer is a positive and a negative 3 root 2. That was a long way to go for an answer, wasn't it? So I don't know how much you remember about breaking down square roots, but I'll try and do some of these along the way to help you remember from Algebra 1. Okay? So, simplifying square roots. The fastest method is simply to look at the number and figure out what the largest perfect square is that goes into it. So if you have those first 10 perfect squares memorized that I shared with you on one of the previous slides, 1, 4, 9, 16, 25, 36, you can kind of just take this number in parentheses and divide it by 2. What's half of 72? Well, 72 divided by 2 is 36. Well, does 36 go into 72? And the answer is yes. 72 is the square root of 36 times 2. And we know the square root of 36 is just 6, and there's no square root for 2, so you leave it in. Okay? So what's the largest perfect square in 90? Well, half of 90 is 45. Well, that's not a perfect square. So working our way down the list, what's the next lowest perfect square? So 45 moving down, 36 doesn't go into 90. Move on down, 25 doesn't go into 90. Moving on down, 16 doesn't go into 90. Moving on down, 9. 9 is the largest perfect square in 90. So this is square root of 9 times square root of 10. The square root of 9 is 3, and the square root of 10 is just the square root of 10. So that's simplifying the square roots. That's kind of the fast way, the fastest way to do it. The other way is method 2, which takes a little longer, and that's doing the factor tree like we were talking about before. So you could say 72 breaks down into like 9 times 8. Then you could break 9 into 3 times 3, and you can break 8 into 2 times 4. And so you're finding the prime factorization. I'm just going to bring all those down, and then 4 splits into 2 times 2. And finally, all of these are prime numbers, right? I can't split them down any further. So for every pair, right here, circle the pairs. Pair of 3s, pair of 2s. Write one of the matching pair outside the radical. So I'm going to write a 3 outside the radical times, I'm going to write a 2 outside the radical. And then everything that does not have a match stays inside the radical. Well, that's this lone 2 right here. And if you take out more than one value, just multiply them together, and that's 6 root 2. Okay, so how about that 90 then? Well, 90, I think immediately to myself, 9 times 10. And then I'm going to break 9 into 3 times 3, and 10 into 5 times 2. And, well, there's a pair of 3s. So 3 gets out, but 5 times 2 stays inside. And I multiply those back together and just get 3 root 10. Okay? Hopefully you remember that, like I said before. So let's practice with some of these irrational values then. So rational numbers would be ones we can take the square root of. Irrational values then include the values that we cannot take the square root of. So let's just do this first one together. I'm going to isolate the a squared because I don't have any other a term. I'll subtract 4. Gives me negative 180 equals negative 5a squared. I'm going to divide by negative 5 on both sides. Anybody know what that is? 180 divided by 5. I think it's 36, yeah. So we get a squared. I thought these were going to be irrational. I didn't get an irrational there. Square root of both sides gives me positive and negative 6. Huh. Oh, let's try this next one. This one's going to be irrational. So it's got just a y squared, so I know I can use square roots to solve. So I'm just going to add 7. And so negative 25 plus 7, I think that's negative 18, right? Divide by negative 1. And that's positive 18. And I just need to break that down. 9 times 2, 3 times 3 times 2. Pair of 3s, 3 gets out. 2, no pair stays in, plus or minus. Okay? So we're square rooting at this point, those both sides there. Okay, and then you try this next one here. All right, let's see. Do you get some to try on your own? No, you try this one then. All right, hopefully you shut the video off and tried this, and you saw negative 96 equals negative 3 m squared. I'm going to divide by negative 3. M squared equals 32. And so square root both sides. So m is going to be, well, let's see, 32. I think 4 times 8 when I think 32. 2 times 2, 2 times 4, 2 times 2. So I got a pair of 2s and another pair of 2s. So and then there's this lone little 2 right there that's left out. So I'm going to take out 2 2s. And then I got a 2 right here that got left inside because he doesn't have a pair, right? So 2 times 2 root 2 is going to be positive negative 4 root 2. Okay. All right, the factoring method. Well, hopefully you remember how to factor. So now this is going to be used, we're going to try to factor everyone, right? But most quadratics don't factor, let's face it, right? So write the equation in the standard form first. So you're going to have x squared, then the x and the constant, all on one side of the equation, and we want to set it equal to 0. If there's a GCF in those 3 terms, we want to factor that out first. If the equation only contains x squared, we can try and factor it as a difference of squares, or can't we just use the square root method we did before? Yeah, but let's say we wanted to factor instead, then we can try difference of squares. If the equation contains x squared and x, then we're going to try and factor it into two binomials. And when we're done factoring, if it factors, we're going to set each factor equal to 0, and that's going to give us our solutions, or our roots, or our zeros, okay? So here's why that works. So the zero product property simply states if you multiply a and b together and get 0, one of the two's got to be 0, okay? So a and b in this case, a is this x minus 7, and b is the x plus 5. So what we're saying here is basically either x minus 7 is 0 or x plus 5 is 0. And these are going to give us our solutions when we solve. And we simply add 7 and subtract 5. And the two solutions to this equation are 7 and negative 5. Okay? That's due to the zero product property. So here's example 1. First question, is it in standard form? Yeah, it is. Everything's on one side of the equal sign. It goes x squared x and then the constant. Does it have a GCF? Is there anything that goes into x squared, 2x, and 80? No. I mean, x squared is only divisible by x, but they don't all have x because 80 doesn't have an x. So I'm going to try and factor it like I learned back in Algebra 1 into two sets of parentheses. Each one's going to contain a binomial, or two terms, connected with addition or subtraction. And so to get the first place in the parentheses, you have to ask yourself, what do you multiply to get x squared? And well, that's just x times x. Well, then you got to figure out how you're going to make 80. What do you multiply to get 80? Well, it could be 1 times 80. It could be 2 times 40. It could be 4 times 20. It could be 5 times 8. That's not right. 5 times 16. 6, no. 8, 7, no. 8, yes. 8 times 10, 9, and we wrap back around. So those are all the ways to make 80. But we need a way to make 80 with two factors that'll somehow give us a middle term of positive 2. Now, what am I saying there? Well, I'm going to just cheat and tell you it's 8 and 10, right? And show you why it's 8 and 10. What you need to do is realize that this pairing, x and x, gave us the x squared. And the 8 and the 10 gave us the 80. The middle pair and the outside pair are the two responsible for this middle term right here. So 8 times x is 8x, and x times 10 is 10x. And the question is, can I combine those in such a way as to get 2x? And I can. I can make this a negative 8x and a positive 10x, and they combine to give me 2x. So the 10 must be the positive, because it gave, the 10 was used to get the 10x. And the 8 must be the negative, because that's what was multiplied to get the negative 8x. And so I don't have to show this red work. This is me checking that I've factored correctly. So yes, x minus 8 and x plus 10 are my two factors. Now I move on to solving by using the zero product property. Set them each equal to 0. And then you just add 8. And you get a positive 8, and you subtract 10, and you get a negative 10, and those are our two solutions. So look at the x, the highest power in this equation is a 2. It's a quadratic, which means we should get two solutions. It doesn't mean we always get two solutions, but we could get up to two solutions, okay? So that's why we're getting two answers for these. Linear equations, power of 1, we only got one answer. So you want to try this one? Stop the video if you need to. So x squared comes from x times x. 15 doesn't have a lot of choices. I always do 1 in the number itself to start with because a lot of people just forget about that pairing. 3 times 5, that's my only choices. I need to get 8 in the middle. Well, the 3 and the 5 can give me that 8 as long as they're both negative. Negative 3 times x, and then x times negative 5 makes negative 5x. Together they combine to negative 8x, and then set them equal to 0, and I get 3 and 5. Okay? So here's a little more difficult. those were pretty easy because the leading coefficient was just a 1 in front of those x squareds, and that tends to make the equation much easier to factor. What happens when you've got something other than 1 out front? Well, that's a different story, so let's talk about it here. So we're going to factor these, right? So that's what it says. So, there may be other methods at work, but we're going to try factoring. So on this one, we want to move everything to one side of the equation. That's always the first step when you solve quadratics. So I'm going to add x to both sides, and I'll just line it up underneath its like term. And I'll add 8 to both sides like this, okay? And so these cancel, and that gives us our 0 over here. And negative 9 plus 8 is negative 1. And negative x and positive x actually cancel, and then I've got a 4x squared. So I've got two terms here, and I've got an x squared, and I wonder if you remember something called the difference of squares. Well, the difference of perfect squares is anything of the form a squared minus b squared. And the way it always factors is it factors into a plus b and a minus b, because what happens is the a times a gives us the a squared, and the b times negative b gives us the minus b squared, but then look what happens in the middle. You get a positive ab and a negative ab, and they cancel out, and that's why there's no x term. Okay, that's why there's no middle term here, okay? So this one factors then into, let me get my blue going. I'm going to take the square root of 4x squared. It's going to be 2x plus the square root of 1, which is 1, and 2x minus 1. That's how it factors. Now set them each equal to the 0. And I'm going to add or subtract 1 on this one, and then divide by 2. And then add 1 on this one, and divide by 2. They don't always work out to be the same value, positive and negative. This one just happened to, okay? Well, yeah, actually, these do. Yeah, difference of squares will do that. There you go. Now you try the next one. Then, well, I don't know. Yeah, I guess give it a try there. Why not, right? Okay. I'm going to subtract 3x here from my linear. Subtract 10 from my constant. My equation then is equal to 0. Now I get a negative 11x and a positive 2. So this one you can try and factor into two binomials. It doesn't just have x squared. It's not a difference of squares like we saw up here. But I think maybe your question is going to be, if I just have 2 times 1, how am I going to get 11 as my middle term? Well, let's focus on the first term. In this case, it's not just x squared, so it can't just be x times x. It's actually got to be like 5x times x, right? Because nothing else makes 5 but multiplying, 5x and x. And then, yeah, the 2 and the 1's the only option there, but watch what happens because there's a 5 in front of the x here. If I put the 1 here and the 2 here, look at my middle pairings. 1 times x is 1x. 5x times 2 is 10x, and that's how I get the 11. I need a negative 11, though, so both of these have to be a negative to produce the negative 11. All right, so now I'm going to set each of those equal to 0. 5x minus 1 equals 0, and x minus 2 equals 0. So here x is positive 2. And here I'm going to add 1 and divide by 5, and I get 1/5. Okay, 2 and 1/5 are my answers there. You try this one. X squared minus 33 equals 3. So we've got x squared minus 36 equals 0, because I'm going to minus 3 on both sides, right? So it goes away, and I get negative 36. Now that's the pattern for difference of squares. This is a squared minus b squared. And so the square root of x squared is x, and the square root of 36 is 6, and I get 1 plus and 1 minus. And so the solution here is negative 6, and the solution here is positive 6. We'll try the next one here. Yeah, I'm going to subtract 6x to start and get everything on one side. We've got a cancellation there. We get x squared minus 49 equals 0. And you know, we could move the 49 to the other side and take the square root and get positive negative 7. But I want you to see the pattern here and just refresh your memory. This is a squared minus b squared. And there are going to be times where we can't solve this that way, as we see in higher difficulty equations. So we do need to know how to find the two factors, x minus 7, x plus 7, right? And here x would be positive 7, and then there would be negative 7. Okay? All right. Can we factor anything out of this? Yeah, this time everything's on the same side, but look how they have an x in common. So if I factor the x out, it looks like this, x times 3x minus 5, because if I distributed that back, x times 3x would give you 3x squared, x times 5 gives you the 5x. And then this is factored, and x gets set equal to 0, and one of the solutions is 0, and then you set the other factor equal to 0, and add 5, and divide by 3. So my solutions are 5/3 and 0. Try that next one there. All right, so factor the x out, and you're left with x plus 1. And then you set them each equal to 0. And you get negative 1 and 0. So factoring by grouping. I don't know if you've learned this one or not. I'm going to show you this. You're going to write the polynomial in standard form, so meaning putting everything on one side, and you're going to put them in the order of their power, highest power first, and then decreasing power down to the constant. Then you're going to factor out the GCF from the first two terms, so it's called grouping because you're going to group together the first two terms, and you're going to group together the second two terms, and you're going to ask yourself, what do they have in common, those two terms, right? And you're going to factor that out. The remaining binomials form the remaining binomials from factoring, they need to match, okay? If they don't match, you can't continue on with grouping, okay? But if they do, there's a common binomial that you can then factor out and write what's left in parentheses. So it's harder to visualize when you put it in words, so that let's just do the problem and you can see how it works. So everything's got to be on one side of the equal sign. So in this problem, this question is just about factoring. It's not asking us to solve. So we're going to put the powers in decreasing order. So x cubed, x squared, x and constant. I'm going to group together the first two terms and the second two terms. So what do x cubed and x squared have in common? Well, they have x squared in common. And if you factor x squared out of x cubed, you're left with 1x. And if you factor x squared out of x squared, you're left with 1, okay? Because x squared times x is x cubed, and x squared times 1 gives you the x squared. So you can multiply, distribute back, and see that you factored correctly. Now, in this next one, because there's a negative 7 in front here, and they have a 7 in common, I need to factor out a negative 7. So I'm going to put negative 7 here. And then if you divide negative 7x by negative 7, you get x. And then positive 7 divided by negative 7 is negative 1. Now just double check. Does multiplying this back out, does distributing this negative 7 give us what we had originally? Well, negative 7 times x is negative 7x, and negative 7 times negative 1 is positive 7. Just remember, anytime that the first term in that second set is negative, you want to pull the negative as well. Now notice, these two binomials are the same. They are a factor that I can factor out of this expression that I'm looking at. So I can pull x minus 1 out, and then if I factor that out, what's left is x squared minus 7. So those are my two factors, okay, and you've just done grouping. Now, if this were an equation and equaled 0, we'd set them each equal to 0, and we would solve. So you guys try and factor this next one here. All right, so I'm going to group those and group those. So these two have an x squared in common again. So x squared. That leaves me with 2x minus 7. And these have a positive, this time there's a positive plus sign there. So positive 8. Can't forget to put the positive 8 down there. And then we get x minus, oh wait, these don't have an 8 in common, do they? What do they have in common? What goes into 8 and 28? How about positive 4? There we go, and we get a 2x minus 7. Oh, that's it. 2x minus 7 is the common factor. If we factor that out, the remaining expression would be x squared plus 4. Okay? Let's do the solving by grouping now. So we're going to group these up. That's already set equal to 0 for us. I'm going to pull out an x squared again. They seem to like that x squared being the common factor up front there, and then x minus 5. And then there it's a minus sign, so I'm going to pull out a negative, and I'm going to cheat. See, I've got to get x minus 5 from my other binomial, so I know I'm going to factor out negative 14, because that's going to leave me with x, and then negative 14 times 5, it's got to be negative 5, gives me 70. So negative 14 times negative 5 makes positive 70. And so you see this common factor now of x minus 5, and we factor that out, and what remains is x squared minus 14. So set each of those equal to 0, and x is positive 5. And then x squared minus 14 equal to 0, and we get x squared equals 14, and then I take the square root of both sides, and x is the positive negative square root of 14, and I don't think that simplifies. Like, the only thing you can break 14 in is 2 and 7, so there's no pairs to factor out there. But notice this again. See how the highest power was x cubed? Well, that tells us that we should and could have 3 roots, and we do. We have 5, positive root 14, and negative root 14. You guys try the next one. All right, it's just 16 going to 112. It does, 7 times. How about that? So I'm going to factor out a 16 and an x squared, and that's going to leave me with an x there and a plus 7 there. And then this next value is negative 9, so I'm going to factor out a negative 9, and I'm left with x and plus 7. So x plus 7 is our common factor, and 16x squared minus 9 is what remains when we factor that out. Well, this is going to give me an answer of negative 7, and then this is going to take a little more work. So there's that 16x squared minus 9. That's a difference of squares again. So this is a squared minus b squared. So the square root of this is 4x, and the square root of 9 is 3, and then 4x minus 3. And set them each equal to 0. That's going to give me x equals minus 3, and divide by 4. And on this one, it's going to be x plus 3 divided by 4, not 2. So there's our 3 solutions. We got a cubic equation there. So we're actually seeing how to solve some cubics. So you can go to that assignment in Delta Math and work through each of those skills there. Okay, this is a long lesson.